Question 3. Atoms are very small and most of their mass is concentrated in the nucleus. Electrons orbit at different distances from the nucleus. 3a. A nucleus is much smaller than an atom. Approximately how many times smaller is a nucleus than an atom? Tick one box. So how many times smaller is a nucleus than an atom? Well, I'm afraid this one here you just sort of need to remember, I guess. So we know that the atom is about 1 times 10 to the minus 1 times 10 to the minus 10. So 10 to the minus 10. Let me just write that out again. So an atom is around 1 times 10 to the minus 10 meters across, approximately. And the nucleus is much, much smaller than that. It's 1 times 10 to the minus 14 meters across. So how much smaller is it? Well, what we can do is if we look at these two, then this one is 1 times 10 to the minus 4 times smaller. Okay, now what I might choose to do instead is do it with my calculator. So my calculator here, and I know that the atom is 1 times 10 to the minus 10 is that, divided by 1 times 10 to the minus 14, which is that, gives me a grand total of 10,000. And if your calculator comes out in standard form, then hopefully you'll know that the ENG button is your friend here. So if it comes out as that, it's standard form. If you press Shift ENG, okay, then you can play around with that until you get 10 to the 0, and that number there is the real number. Okay, so 10,000 times smaller. So the answer is that one there. It may well be that you just remember that the nucleus is 10,000 times smaller than the atom. B. The electrons in an atom can only orbit at specific distances from the nucleus. State what causes an electron's distance from the nucleus to increase or decrease. So why might it move from the nucleus? Well, you can only move, things only move when they absorb energy. So increase, they absorb or take in energy. Now the easiest way to do that, the most common way of doing that, is from an EM wave, an electromagnetic wave, from an electromagnetic wave. Or potentially they could do it from electrical current, but the most common way is an electromagnetic wave, e.g. let's go for, I don't know, infrared, say. Okay, and that's what happens. Or radio's a good one as well. So radio, that's how electric currents are generated in radios. They absorb, the metal absorbs the radio wave. The electrons then get excited. And the opposite has happened when they decrease. So when you decrease, if you increase, you absorb energy, so you gain energy, you jump up to a new level. So imagine you're jumping up a step. You're going to do that when you gain energy, and when you lose energy, you drop. So they emit. So decrease, they emit or release energy. As an electromagnetic wave, electromagnetic. You could easily write EM there if you prefer, EM wave. And that's what's happening right now in the lights in the room that you're in. Energy's been absorbed by electrons, and as they emit, as they relax, they emit that energy as light. Part C. Atoms have different atomic numbers and mass numbers. In terms of subatomic particles, describe the difference between an atom's atomic number and its mass number, and it's worth 2 marks. Okay, so describe what atomic number is and describe how that's different to mass number. So atomic number equals number of protons. Number of protons in an atom. In fact, we know it's the nucleus of atom. And then we know the mass number equals number of protons plus neutrons in nucleus of atom. Now, if you know that the mass number is equal to the number of nucleons, okay, if you said nucleons for here, then that's fine. But I would also make sure that nucleons, you know that nucleons, you show the examiner, sorry, that you know that nucleons equals neutrons plus protons. Okay, so if you say that the mass number is the number of nucleons in an atom, that's fine, but make sure the examiner knows that you know it's neutrons, that nucleons are neutrons plus protons.